today questions of leetcode by expert hunter. So today questions we have 2256 minimum average difference, in which the statement is saying that you are given a zero indexed integer, right? We have given a zero index integer, correct? And the array name is nums of length. What we have? Array nums we have, right? Nums length we have. Okay. Give me 1 minute. Okay. Oh yeah. So we have given and what is the array name is nums and of length n. The average difference of the index I is the absolute difference, and we have to find the first I plus 1 elements of the nums and the average of last n minus 1 for the index I, right? And then we will find the absolute difference, and that calculated average difference we have to store somewhere. Okay. And now we're setting the both average should be rounded down to the nearest integer, and we have to return the index with the minimum average difference. So let's first we will understand this problem. Okay, we have given an example here in which this is the array, right? This is the array 253953, right? So the difference we have to find how. So why this output is 3? Okay, now as you can assume that the average difference is giving the explanation of at index 0 is 2 by 1, right? The first index at 0, what we have? 2 we have, right? Index at 0 is 2. So 2 by 1 minus the rest of the element from after 2. Okay, minus we have to calculate, we have to add, and then we have to divide by 5. So all element, how many element? 1 2 3 4 5, total 5 element. Then we have to divide, and this is one element, so we have to divide 2 by 1 element, and then we have to find the after dividing, after the sum we have to divide, and then after divide we have to do minus, and then the final value will come, that is called the average difference at index, whatever the index we have, right? So in this way we have to calculate all the you can say average at index, and in which we can see that this is the zero value, or the least or smallest, you can say the average difference at the index 3 we have, and that's why the index 3 we are returning here, right? So index 3 we got the minimum average difference, so we are returning index 3. Okay, let's understand the another example that we have. If the base case you can write, if the num contains only 0 value, then we will return 0, because there is only index is 0, so we will return 0 only, right? Like this calculation. Okay, so understand what does it mean. Okay, so let's overview the problem, what the problem is saying that. So a problem is saying, given an array nums, we need to find the index that divides the array into two parts, where the difference between the average of the left part of the array and the right part is minimum. So an index I will divide the array into two parts. The first part will be what if the index we contain index I, right? So index I will have the elements from what? 0 to index, and then second part will have index I plus 1 to the last index, correct? Means if we consider the index at 5, right? This is the index at 5, this is the index is 5. You can see that 0 1 2 3 4 5, correct? Now we have 6 7 8 9. If we consider that I is what? 5, right? So we have two parts here. The first part is the left part of the array from 0 to what? 5, and the another part we have I plus 1 means 6 to 9. So these two sum we have to calculate, right? And we have to divide, we have to make the average, left part of the average and the right part of the average we have to calculate, and then we have to divide, and then we will find the floor value of the average, like 3 and 2, and we will make the difference 3 minus 2, and that will be our index at 5 value we have, right? The average. Okay, so in this way we have multiple approach, in which we will first go through the brute force approach, in which we will understand how to we calculate and will get the index of the minimum average at an index. It means that this approach is not good, but this approach is not good because we have to optimize this one. So let's look at the first brute force method first, and we will try to optimize it further. The most naive method we can think of is iterating an every index I of the array and then finding the averages of the left and the right part of the array broken at index I and finding the difference between them. So note, firstly we would need to iterate on every index of the array to consider the index as a breaking point, and then iterate all the indices again to iterate on both part of the array to calculate their respective average. As you can see, this method is not optimal, thus we will result in a time limit exceed, and but it will not be a stepping stone to the further approaches, but it will help you to understand the other approaches. Okay, so as you can see that if we are considering at index 0, right, this is the initial array we have, right? But in initial array, if we consider I at what 0 means, this is the left part of the array, and if we calculate the sum I by 1 by 1 is, we will get the left part of the average array is will get 1, and the next right part of the average will get 31 by 9, and we will get the float value 3. Similarly, we will move to the next index, right? We have started from 0 to now 1, and the left part will be now we will calculate 1 plus 4 equal to 5. 5 by 2 is equal to 2, the float value, and remaining is 27 by 8, that we will get what 3. Okay. Similarly, we will move to I now 3, right? I 0 1 2, correct, and then we will find we will make a sum 145 by 3, and then we will get what 3, and the rest part is 22 by 7, then we will get 3. In similar way, we will move to the next till the position that we have, we will calculate, and then we will give the final answer. Okay, so final answer what will we have? We have already calculated all the left part and right part, and then we have made a difference, and we will we will store somewhere, and in some, you can say, some array we will store, and then we will check the list minimum. Okay, what is the minimum average we have, that we will find out. Okay, now what should be the algorithm should be here, right? So we have to initialize the variables and integer to store the number of elements in the array, then mean average difference, that initialize the large integer value, store the minimum average difference, and the answer to store the index, we will find the minimum average difference, right? That will be the answer. So we have to iterate over each index of the array that given elements we have, right? We will have, and then at each index what we will do, we will add all the elements from 0 to I, and we will divide by I plus 1, and another what we will have, we will start from I plus 1 to n minus 1, and we will divide by n minus I minus 1 to get the average of the right part of the array. And if the difference the last part is what, if the difference of the average of the left and right part is similar smaller than the minimum difference, then we'll store the difference in the mean average difference, and the current index I in the answer, and we will return the answer that will got. Means we have to update each time the minimum average difference, and if the minimum average is at index I, then we will return the index. Let's understand the problem here. So as you can see that we have as per the algorithm, we have initializes n equal to nums dot length. We will have the size of the length now array, and then we have answered, we have started with we don't have the index number right now, so we will initialize with -1, and the last one is we have mean average difference, that will take the max integer value, and to compare the minimum average, and will update these variables according to the each index. Okay, So you can see here that we have difference, left part of average is 0, we have started, and as we know that we have to start the index from 0 to less than n, because the array we are traversing. So we will calculate the left part average, and we will do plus, and we will calculate from 0 to index less than equal to index, and then right part of the index will start from what, index plus 1 and less than n will go, and we will have the right part of the index. Now we will check if index is not equal to n minus 1, then we will, what we will do, we will start calculating, right part of average divided by n minus I minus 1, right, that is the index minus 1, correct. Now we will have the left part and the right part, we will do minus, and then we will find the absolute value, the float value, and we'll store in somewhere that is called the current difference, right. Absolute value we will get, and then we will take a current difference, and if the current difference is less than minimum average, right, so we will update the minimum average is equal to current difference, otherwise we will not go here, and we will update the answer as an index, because as much the current difference is less than minimum difference means the minimum difference we got, right, and we will update the minimum difference accordingly. So the lowest minimum average we will have in the minimum difference average, and we will update accordingly to the current difference. So we will, at that time we will have the index, and that's why we are storing the index here. And finally this loop will continue to 0 to n index, and once the index is reached nearby n, then we will return index, we will return the answer, and that will be our uh, answer. Okay, but the problem is that the leetcode will return you the time limit exceed, and it will not the good approach, is the worst approach. So that we will go to the complexity now, and we'll understand the time complexity will, because we are comparing each element, right. So time will be O n square, and space complexity will be remain at 0.1, because we are not taking extra space here. Now we are taking the another approach, that is the prefix sum. So first of all, if you don't know, the prefix sum is the technique where we generate a prefix array, and its element at I plus 1 index store the cumulative sum of all the elements from 0 index to index I. So if you carefully notice, when in the previous approach at index I, we need sum of all the elements of nums array from 0 to I, and thus we can conclude that we can use a prefix array instead of iterating again on all the elements. We don't have to calculate multiple times, right. We will have the prefix already, and we don't need to iterate again. Okay. Now the third one is that, just like previous sum, we can store a suffix sum for the nums array to get the sum of all the elements from I plus 1 to the last index in the optimal way, and that's why we don't need to do the iterating again and again to do the sum. As you can see here, we have two parts, left part of the array and the right part of the array, correct. There is left part of array and right part of the array. So the left part of the array is how we will calculate that, we'll take at index 0, right, and it will start with the 0. Okay, now 0, this 0 and this 1 we have to do sum plus. So the next at index 1 we will, what we have, 0 plus 1 is 1. Now this 1 and this 4 we will have to add, 1 plus 4, now we have the 5, and similarly 5 plus 5 we have 10, and 10 plus 6 we have 16, and like that we will got the 19, right. Similarly, if we will come for the suffix, right, we will have suffix, and similarly we will move on like this one. Okay, and if we'll come to the suffix array, we'll start from the 0 same way, and we'll 0 plus 1, the last index we had, what we have 1, so we will have 1. Now 1 plus 1 is 2, 2 plus 2 is now 4, these 2 and these 2, correct. Now we have 4, and 4 plus 6 is what, 10. In this way we'll move to this way, and we will have suffix and prefix, right, both array we have. So we want to find the average of the left and the right part of the array at index 4, correct. And for that, what we have to do, we have to do left part of sum. How? Prefix at 5 and minus prefix at 0 for the index 4. Okay, and we will have the prefix 5 here, correct, and we will get the 19 here, correct. So 19 by 5 is equal what, 3. And similarly prefix 5 minus prefix n we'll get what I will check here 0, right? So we have 13, so we will divide by 13 by 5 equal to what? 2. So we will have the left part and average part, in which we are not iterating multiple times. We will have on direct, we will calculate through the, because the array will already have prefix array we have and suffix array. So we will already, we will pass the index and we will calculate the left part and the average part similarly. Okay, so this is the algorithm, and I think we don't need to go through. So if you want to go through, just pause it and read it. Now coming to the solution implementation part, right? We have we have to initialize the same way, int n, answer, and minimum average, but only two extra part we have to add: the prefix sum and suffix sum, and that is a type of array. We'll start we will add n plus 1. We'll take the size of the both array. So in this way we will calculate and we will add, we will store the prefix sum, and like prefix sum of index 0 is 0, and index 1, whatever the data we have, that we will calculate and we will store in the index I plus 1. So we will take the, we will calculate the suffix sum, and will store in this similar way, correct, the 0 index and the index at what we have the data. And the finally what we will do, we will start from 0 index to what, n, right? This loop will calculate, I will iterate. Then we will take left part average, and left part average is prefix sum index plus 1, because we do not need to calculate from index 0 to index I plus 1, right? And the left part of the average, what will have, index I plus 1, that we have to divide. And right part of average, what will have, the suffix sum index plus I plus 1, and we'll take a condition if the right part have 0 element, and we don't have to divide it, right? So what we will do, index not equal to n minus 1, then we will do what, right part of average n minus index minus 1, that you know already this one, right? Now we have to find the absolute difference, right? Left part minus right part, and that is called the current difference. If the current difference is less than minimum average, right, then we will update in this similar way the last program we have did. We will update the minimum difference, and we will store the answer, we will store the index in answer, and we will finally, the loop will end, the for loop will end, then we will return the answer. In this way what will happen, we will have the time complexity on square. Okay, what we have, the time complexity is on square, and space will be on, because we are taking array of size n. So next approach, in which we will optimize the prefix sum optimize in our runtime. For the previous approach is fairly efficient, but we are using some auxiliary spaces. Let's try optimize it now. We are using two arrays, prefix sum to store the sum of the all the elements of the array from 0 index to index I, and to get the left part parts of the sum, suffix sum to store the sum of the element from index I plus 1 to the last index, will get the right part of the sum, correct? But if we already had the sum of all the elements of the array, then we can extract the left part of the sum from it to get the right part of the sum. Thus we can discard the suffix array, and we will only use the prefix sum array with the total sum, total variables. But further we can notice that while iterating on every index for the breaking the sum array into two parts at that index, every time we only use the value at the current index I from prefix sum, right? Prefix sum array, you can say. Thus instead of storing all the prefix sum in the array, we can store the prefix sum till I and in the variable. So we can also discard the prefix sum array, and we will use on the current prefix sum variable instead of it. And thus instead of two array, we can only use two variables, total sum and current previous sum. So let's understand in this example. So we can visualize this using these slides, right? So total sum, what we have, total sum is 22. Initially we iterate over whole array, and we have find the total sum. So now we start iterating on array once again to break it into two parts, right? So if the index is at what, 0, and left part is what, 1, and the rest of the part is right part. So at index 0, what happened? Total sum is 22 and current prefix sum is what? 1. So answer is what? Answer will be 3. How? So we are at index 0, right? We are at index 0 and nums to current prefix sum, right? We will do 0 plus 1 is 1, and the total sum will what happen? Total sum we know 22 and the current sum is what? 1. So it is 21 minus 22 minus 1 is 21, and so the left part is 1 by 1 is 1, and right part is 21 by 5 is equal to 4, correct? The floor value. And so that the difference between 4 minus 1 is what? 3, and that's why we have the answer is 3. And in similar pattern we will move and we will calculate the sum, we will make the difference, and we will calculate the average difference. We will store at each value. So current answer will be 1, like that. See, now the answer is what? 3 minus 3, 0. And in similar fashion, what we will do? We will reach to the last index, and that what we have, 22 minus 22. Last will we have 22 minus 2. We'll have the total sum is 0, and the left part is 3 and the right part is 0. So 3 minus 0 is equal to what? 3. So we don't update answer now, and we will move to the next index, and we traverse all the indices. Thus the index where the difference between the averages minimum is 2, correct? Okay, coming, you can pause it and you can understand. Let's come to the problem here, implementation part. Okay, so where we are here. So we have we will initialize the variable int an answer and mean average, and one will take one the current sum, current prefix sum. We will use the current prefix sum, but we don't have now the prefix array and suffix array. We'll not take this. What we'll do, we'll start the total sum from we'll start at 0, and we will iterate 0 index to last index, and we will do a sum. We'll do for total sum of the array, and from we will make another loop, and we'll start from what? Index 0 to index n, and we will calculate the current sum. We will have the current sum, and we'll start from the num of x index. What we'll do here, we will take left part average is the current prefix sum, and we have what we have to do, left part divided by index plus 1 we will do. So we will have the left part average, and we will update the left of average divided by the number. Now we have the similar fashion, we have right part average, and we'll do total sum minus current prefix sum. We'll take the index not equal to, should not equal to n minus 1, so that we cannot divide by 0, and that's why right part is divided by what? N minus index minus 1, and we'll find the absolute value, right? And we will have the current difference, and similarly we will update our minimum average difference, and we will store the index into the answer, and after the loop is completed, we'll return the answer. So in this fashion, what will happen? We are not taking extra space. We will have a space complexity as 1, and time complexity will remain the same, ONs. Okay. So if you have any doubt in this problem, please ping me in the comment box. I'll share the my thought. Thank you so much.